I wanted to take a moment to do a proof of the quadratic formula. And remember that whenever we're solving a quadratic, we're setting f of x equal to 0 because what we're looking for is we're looking for that part of the parabola, or up to those two parts of the parabola, where the parabola crosses the x-axis. And these two parts are called the roots. Another term for the roots would be the x-intercepts. And so what we're looking for is, if I were to set f of x equal to 0 or y equal to 0, depending on how you've written or encountered your equation, then when y is 0, what is x, right? So that's what we're going to do. We're going to take our quadratic equation in standard form, and we're going to set it equal to 0. And then we're going to complete the square in order to find out what x is. So in order to complete the square, the first thing we have to do is divide by a, because we want the coefficient of the x squared term to be 1. So we've got x squared plus b over ax plus c over a, and that's going to be equal to 0 divided by a is just 0. Any number, 0 divided by any number is 0. And now in order to properly complete the square, what I need to get my constant term to this side of the equation. So I'll do that by subtracting c over a from both sides. C over a from both sides. And here those will cancel. And I'll be left with x squared plus b over ax negative c over a. Now, in order to complete the square, since I have only x terms on this side, to complete the square, what I'll need to do is, let's see, I have to take half of my b term. Remember, you have to take half the b term and then square it. So if my b term is b over a, my b coefficient is b over a, and I take half of that, then that would be b over 2a. And I'll need to square that in order to add it to both sides. So that'll be plus b squared over, let's see, a at 2 squared is 4, a squared is a squared, so 4a squared. So that'll be a plus b squared over 4a squared. And now what I can do is, since I have a perfect square trinomial, that's what completing the square does for us. It gives us that wonderful little perfect square trinomial. Then I can just factor it out. It'll be the quantity, the square root of this term here, x, plus this plus, because we got a plus here in our middle term, b over 2a, right? That's the square root of that over the square root of that. And to completely factor this, it'll be that quantity squared. And we'll set that equal to, let's see if we can't clean this up a little bit. That'll be, we'll need to make a common denominator so we can put it all over one denominator. And 4a squared is going to be our common denominator, so we'll have to multiply numerator and denominator here by 4a. So the common denominator is 4a squared, and that'll be a negative 4ac plus the b squared all over 4a squared. So to unpackage that, let us take the square root of both sides, square root of both sides. And when we do, we'll have x plus b over 2a, and that'll be equal to, our denominator here will, it's a perfect square, so that'll come right out. That'll be 2a in the denominator. Our numerator, on the other hand, is going to take a little bit more work. First of all, it'll be plus or minus the square root of, and I'm going to go ahead and rearrange this into descending order, right? So that would be, let's see, it's going to be all in yellow now. b squared minus 4 times a times c. And so now things are starting to become a little bit more familiar. Now, since I have the same denominator here, when I subtract both sides by b over 2a minus b over 2a, I can put all of this over one denominator, which is 2a. It'll be a negative b plus or minus the square root of b squared minus 4ac, and all of that is over 2a. This is x at the roots. This is the quadratic formula.